In this video, we will learn how to calculate deadweight loss in case of monopoly. The question is, for a monopoly, consider the following. P is equal to 132 minus 8x, which is demand function. X is the output, P is the price. Cost function is x cubed minus 14x square plus 69x plus 128. We need to calculate the deadweight loss of the firm. Options are being given. We need to find out the correct option. Okay. So to calculate deadweight loss, what we need to do? We need to find out the 2 pointers. The point where monopoly produces. So monopoly equilibrium condition, we know that for monopoly we equate marginal revenue with marginal cost. Okay, and we compare it with the socially optimal point, that is in case of perfect competition. Okay, the condition is price should be equal to the marginal cost. Okay, so perfect competition gives us socially optimal point. Okay, so the difference between socially optimal point and monopoly point at its equilibrium will give us the magnitude of the deadweight loss. Okay, so let us see how do we calculate. Let's first take the monopoly case, and we have the demand function. This is our cost function. So to find out for monopoly, what we do, we equate marginal revenue with the marginal cost. So first we need to find out the to find out marginal revenue, we need to find out the total revenue. So what will be total revenue? That will be price into output. So price is 132 minus 8x. To this we multiply by x to get the total revenue. So total revenue will be equal to 132x minus 8x square. Now we know that marginal revenue is simply the change in the total revenue due to the change in the output. That is the derivative of the total revenue function with respect to x. Derivative of x is 1, so we are left with 132, and derivative of x square is 2x, so 2 into 8 is 16x. This is our marginal revenue. We are being given the total cost function. We need to find out the marginal cost. We know that marginal cost is simply the change in the cost to total cost due to the change in the output. So the derivative of this function with respect to x, the derivative of x cube is 3x square. By power function rule, exponent becomes coefficient and exponent is subtracted by 1. Minus 2 into 14 is 28, x plus 69, the derivative of x is 1, and derivative of a constant is 0. So for monopoly, what will we do? We will equate marginal revenue with marginal cost. And let me draw the graph here also to make things easier. Graphically, what it implies. So if I draw the graph here, so we have the quantity on the horizontal axis, price on the vertical axis. We have this demand function. Okay, so let me try to draw the demand function. This is our demand function, what we call the average revenue function also. We have the marginal revenue function. It has same intercept as that of the inverse demand function. So let me use another color. It has same intercept. This is our marginal revenue function. Okay, and this is our marginal cost function. So let us say it looks like this, marginal cost function here. Okay, now at equilibrium, what happens in case of monopoly? Marginal revenue should be equal to marginal cost. So equating marginal revenue with marginal cost means we equate 132 minus 16x with the marginal cost, which is 3x square minus 28x plus 69. Solving, so we'll get 3x square minus 28x. Transpose it here, it becomes, if it is minus 16x, it becomes plus 16x. Then we have plus 69 here. Transpose this here, it becomes negative 132. And we set it equal to 0. Solving further, we will get 3x square. So we have 28 minus 16. 8 minus 6 is 2. 2 minus 1 is 1. So we'll get here negative 12x. Now we have 132 minus 69. 132 minus 69. So 12 minus 9 is, which is 3 here. So 12 minus 6 is 6. So we'll get negative. And we set it equal to 0. So this is our quadratic equation. So let us first divide both, since all the terms are divisible by 3, let us divide both sides by 3. Okay, So dividing by 3 here, here, and here. So this 3 gets cancelled. 3 ones are x square minus 4x minus 3 2s are 6, 3 ones are 3. Okay, so splitting the middle term here, so the sum of the two numbers should be equal to -4, and product of the same two numbers should be equal to -21. So if I write here -7 plus 3, -7 into 3, so it solves the problem, because -7 plus 3 is -4, -7 into 3 is -21. So can we write x square minus 7x plus 3x in place of -21? Can I write -7 into 3 is equal to 0? So let us take x common from the first two terms, so we are left with x minus 7, and let us take 3 common from the last two terms, we are left with x minus 7, and we set it equal to 0, which implies if I take x minus 7 common, we are left with x plus 3 should be equal to 0. It implies either x minus 7 is equal to 0, or x is equal to 7, or x plus 3 is equal to 0, or x is equal to -3. Since quantity cannot be negative, we take the positive value. Okay, so which implies our optimal point at monopoly will be x will be equal to 7. Okay, monopoly will produce 7 units of output to maximize its profit. Okay, so when we equate marginal revenue with the marginal cost, we got the optimal quantity as 7. Now what will be the price? So x is equal to 7. Now what will be the price? P will be equal to, plug x equal to 7 into the inverse demand function. We have 132 minus 8 into 7. So price will be equal to 132 minus 56. Okay, so let me now rub this. So we have 132 minus 56. 132 minus 56 is 12 minus 6 is 6. So 12 minus 5 is 7, I guess. Okay, so price will be equal to 76. So P is equal to 76. Monopolist will charge price of 76 units and produce 7 units of output. Okay, so it is here 76. Okay, now we need to compare it with the socially optimal output, that is when we are producing. So for socially optimal point, okay, what should happen? So in case of perfectly competition, we will equate price with the marginal cost. So price should be equal to the marginal cost. So what is price? That is 132 minus 8x should be equal to the marginal cost, which we calculated as 3x square minus 28x plus 69. Now let us solve it again. So we have 3x square, transpose it here, or we have -28x first, transpose it here, it becomes plus 8x, then we have plus 69 minus 132, and it should be equal to 0. So we have 3x square minus 28 plus 8, it is minus 20x, and we calculated it as -63, and it should be equal to 0. Now we have again the quadratic equation. We cannot separate middle term because the coefficient of x square is 3. It should be 1 if we want to use the separating middle term method. Okay, so using the quadratic formula, so this is a, the coefficient of x square, b is the coefficient of x, c is the constant term, which is -63. So what is the formula? That is x should be equal to minus b plus minus b square minus 4ac divided by 2a. So we will be using this very thing. So our x will be equal to, so minus from the formula, then we have minus 20, okay, plus minus b square minus -20 square, then we have minus 4 A is 3 and C is 63 but negative. Divide by 2 times A. 2 into A is 3. Solving it. So minus into minus is plus, we get 20 plus minus. Square of a negative number is positive, we get 400. Minus into minus is plus, so 4 3s are 12 into 63. So we have 63 into 12. 2 3s are 6, 2 6 are 12. Then we have 1 3s are 3, 1 6 are 6, 6 goes 6, 3 goes 5, 7 goes 7, 5 6 is 7, 5 6 divided by 2 into A minus 2 into 3, which is 6. Now solving it further. So let's add these two terms. So we have 20 plus minus. We have 6, 5 and 11 divided by 6. So let us see whether it is a perfect square or not. So let us, we have 1, 1, 5, 6. Okay. To find out it is square root. So what we do, we make the pair from the right. So we have 3, 3s are 9, 10th 11, 2 are left. So this gets doubled. So 3 goes here and 5 6 comes down. So if I write 60, what number should be here? We have to write that very digit here so that we get 256. So if I write 66 into 6, so let us see, 6 6 are 36, 6 6 are 36. So 256, 6 6 are 36, 6 6 are 36, 6 6 are 36. So let us see again whether 1156. Okay, let us see 1156. Let us take it to square. So we have 3 3s are 9, we are left with 2, 56, 3 plus 3 is 6, 3 3s are 9, so 4 4 are 64 into 4, so 4 4s are 16, 4 6 are 24, which is 25, so we will get 34. Okay, so let me rub this out and let me this clear for you. So we have 20 plus minus 34, so we got here 34. 34 divided by 6, or x will be equal to 20 plus 34, 20 plus 34 divided by 6, or x will be equal to 20 minus 34 divided by 6. So it will be a negative number, we will discard this. So x will be equal to this very term. So let us see, so we go 20, 34 plus 20 is 54, 54 divided by 6. So this is 6 9s are 6 9s are 54. So we will be producing at this point, at socially optimal point, we will be producing 9 units. Okay, and at what price? I hope I am making myself clear, so I get confused sometimes with the calculation. So at socially optimal point, what we are doing, we are producing 9 units of output. At what price? Plug x is equal to 9 in the demand function, so p will be equal to 132 minus 8 into 9, so which is 132, 8 9s are 72, so 60. So price will be 60, and this makes sense. Okay, so P will be equal to 60. Since we need to calculate the deadweight loss, so what is the deadweight loss? It is the difference between the socially optimal point in case of perfect competition and the monopoly point, and the triangle formed by these 3 lines denotes our deadweight loss, the loss to the efficiency due to imperfect competition. Okay, so in case of this, deadweight loss will be equal to it will be equal to the area of this very triangle. But I fear there will be a triangle here. Why? Because we have a marginal cost function which is non-linear thing. Okay, if we want to find out its area, then so since we have this kind of thing, marginal cost is a curve like this, so it is not perfectly a triangle, so it will complicate our things. Then we need to use the definite integral and calculate the area of this very triangle. So let's assume here, okay, I'm not sure whether the triangle will be formed or not, so let us suppose it is triangle. So the area of the triangle is 1/2 of base into height. And what will be the we have 1/2. What is base? Base is 9 minus 7, which is 2. And what will be the height? 76 minus 60, which is 16. So 2 and 2 gets cancelled. (76 minus 16). I hope I have done the calculation right here. But still I am not getting the correct options here. So at monopoly, socially optimal point, we are producing 9 units of output at a price of 60 units. At monopoly, we are producing 7 units at the price of 76. Now the area will be the deadweight loss, will be the efficiency lost due to imperfect competition. So I am getting 76 minus 60, which is 16. Area of a triangle is base into height, so height is 9 minus 7, which is 2. So deadweight loss is equal to 16 here. Okay, so let us set another option. So I am getting 16 here. Okay, so you can comment where I have done the mistake. Okay, but it should be like this. There can be the mistakes in the calculations. Okay, but this is how do we calculate the deadweight loss.